The most common problems you have with these air handlers are the relay, the blower motor relay, or whatever type control it is. You know, it may be a little time delay, solid state thing, or something else. But they either fail to turn the motor on or they fail to turn it off. And then the transformers, fairly regular. Now I've got the clamp meter around that lower, the wire feeding that lower terminal, which is a normally closed set of contacts. So it's closed when the relay's not energized. And if we look at the amp meter, we see that's where our voltage or current's coming from, is through that normally closed side. So that tells us it's got to be coming off one of the sequencers. And at that point, the quickest solution is just to go to each one of the leads coming off the strip heat and see which one's pulling current. So I hooked it around the first one on the right, and you can see it's pulling 13 amps. So there's the problem. So all you got to do at that point is just trace the wires back down to the sequencers and see which one it's hooked to, and you know which sequencers is either being told to be on or it's just stuck on. So at this point, then you'd have to go to the 24 volts on it, or 24 volt connection, and make sure that something wasn't telling it to come on. Now once I found the wire that was carrying current, I just traced it down to the sequencer, and I found it was the one on the right side. So as I say, it's possible the sequencer is just stuck, but before you make that assumption, but you got to check, make sure it's not getting voltage. So I got the meter probes now hooked to the two 24 volt terminals on it, so we'll see if there's any voltage telling it to come on. And as we see, it's not, so we know it's a mechanical problem with that sequencer. Now if you get up there and it's running and you read voltage, then you've got to start backing up towards the thermostat and see where you're getting your voltage from. Now we'll look at just troubleshooting fan motors, blower motors, condenser fan motors, either way. What I'm going to do first of all is this is a new motor that I've got set up. And we'll just start it up and see how they're supposed to start, how they're supposed to sound, and then we'll play with the capacitor and see what kind of symptoms you get when the capacitors go bad. But when they start up, you know, it'll just be a quiet start, fairly quick start, no roars, no rumbles, no grunts, no groans. Okay, now we'll simulate an open capacitor, run capacitor. I just disconnected one of the wires, and we'll energize the thing now and see what it looks like. So it's just sitting there humming. You can spin it, and it'll take off, which is fairly characteristic of capacitor problems. You know, sometimes the blower will start up and run without any help when the capacitor's bad, but a lot of times they won't, and you can spin it, you know, and it'll run. You know, and it seems to be running. Okay, now I've got an old motor that I took off of a heat pump sometime back, which was not, it was a bad motor, and I'm going to start it up and listen to the difference in the sounds. You could hear an obvious abnormal noise when it started up, and then when it got to running, there's a little whine. I don't know if you can pick it up or not with this little microphone. But on this particular motor, I can show you one thing. I can show you the main thing that's wrong with it, which is the bearings wore out on it. But that slack in the shaft, side to side slack, and that's always that's a no-no. If you get one like that, it's not going to, it may run like this and took off and run, but after a while it'll get hot and quit. And the other thing that will mess you up sometimes, that the hub can get loose in its mount to the blower assembly. I went on a package unit one time and I turned it on, and just a few seconds after it started up, the motor, what I thought was the motor, would start making a sound. It sounded just like one that was messed up, making a grunt and growling sound. And I took off and got a new motor, came back and put the new motor on it, turned it on, the same thing. Then I got to looking close. Okay, let's troubleshoot some of the common electrical problems with this ream unit we got here. Of course, the most common symptom when you go on service calls, electrical problems, is the condenser unit's not running. So immediately you got two possibilities. The contactor's pulled in, there's no high voltage, or the high voltage there, but the contactor's not pulling in. So if we came on this unit and we saw that the contactor wasn't pulled in, we could go to the hot side of the contactor coil with our probe and see if we were reading 24 there. Of course, just about be sure you're not. And as the meter says, we're not getting any voltage there. So then we got to back up to the next junction in that circuit, which is going to be the Y out terminal on that defrost board. And of course, the other problem you got, or the other situation, the contactor's pulled in but nothing's running. So in a case like that, you got, I'll say, three possibilities. No voltage coming into the bottom of the contactor or the inside of the contactor, no voltage going out of the contactor, which means the contacts are messed up, or voltage coming out of the contactor and still nothing running, which means the motor and compressor circuits have to be open somewhere. But back to number one, if you open up the panel and you see the contactor is actually pulled in, then you hook your probes to the inlet side, and as you see, we're reading 247 volts, so we know it's coming in. So the next thing to do is go to the other side of the contactor and see if you're getting 240 out. So when I move the probe on the right, well, the top end of the screen, which of course I moved it across the contact piece, then we're reading 0 voltage. So obviously the voltage is not getting through the contact. So the contacts are burned, or there's ants in it, or trash in it, something. It's the only thing that it can be in a case like this. Of course, now the other situation, you got 240 volts coming out of the contactor and still nothing's running. So at this point you need to suspect the condenser motor and or the dual value run capacitor. Now on this particular unit, of course, when you're checking the compressor, if it's trying to run and won't run, I'm just going to use the clamp ammeter just to show you that it pulls, lock rotor amps or something near lock rotor amps. Then you've got to decide if the compressor is actually locked up, or if there's a electrical problem somewhere that's not allowing it to get the amount of torque it's supposed to get. So when you contactor pulls in, you'll see something like this. So that situation, like I say, at that point you don't know. The compressor may be in fact locked up. Unfortunately, unlike fan motors that we can put our hand on the blade or the wheel and spin the motor and see if it's locked up, you can't do that with the compressor. So rather than you don't directly confirm a locked up compressor, you just eliminate the electrical problems that can make it have the symptoms of being locked up.